Hi everyone, welcome back. This session we talk about fields of compiler. In the last session, we would have seen what is a compiler and what is the language processing system. Now, it's very much important to know how does a compiler work. More or less, compiler is not a very simple software which works in a very simple way. It had so many things to be explored one by one. The figure which you are able to see now, which is showing different phases of compiler. Roughly speaking, there are around 7 phases. We talk about lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and code generation. And each phase is taken by a separate tool. We internally call it as a lexical analyzer, syntax analyzer, and so on. This picture or this diagram shows what is the input for each phase and what is the output generated at each phase. Let me understand one by one. Now let me consider an example. If there is a statement int a comma b semicolon. Now I say this is a character string. As a programmer, you could say it is a declaration statement. For a compiler, it's just a set of characters. Now what would happen? In the first phase, this character string or these characters are fed into the compiler, where this is considered by, or it is considered by Lexical Analyzer as an input. It just divides everything into something called as tokens. That means these character string is divided into something called as tokens. Now what is token? Token is smallest addressable unit of a program. How much you can able to divide, that is what is called as token. Now, what does token contain? Token always contains the token name and the attribute value. Suppose in this consideration, if you say int a and b, I say first it is data type because int is a data type, followed by identifier. I say this first identifier, followed by comma, followed by identifier 2, then semicolon. This is how the lexical analyzer splits the character string into what we call it as token string. Also, please do understand, the moment if I say lexical analyzer, it is also called as scanner. It is also called as scanner. Sometimes we also call it as lexer. That means the process of dividing the character string into tokens is called as lexical analysis. Sometimes we also can call it as scanning. Moving on, these stream of tokens what we obtain from here is fed as an input to syntax analyzer. Now syntax analyzer has to check whether it is syntactically correct. Say for example, say this may be now this has to check whether it is syntactically correct. How do I verify? It has to verify through syntax tree. Now you may be having a doubt. How do I verify the syntax part of syntax tree? So for ease of understanding, instead of just writing a b, I would have taken the example as a is equal to b plus c. Assume one more example. Now this can be considered as a token stream as id1 equal is one more token, id2 plus is one more token, id3 as one more token, and followed by semicolon. Let me consider this now. You know b plus c is the first operation to be performed because this is the first operation to be evaluated as per the precedence of operator. This whatever the value we get, we assign it to sum or the value a. Sorry, for the variable a. Now, if you convert this to your syntax tree, you know it is id2 has to be added with id3 and that value is assigned to id1. Now how do I understand this? This set of tokens could be converted as a syntax tree or sometimes called as a parse tree, where it checks for the order of evaluation. You know already what is precedence of operator, what is priority of operator, and also all the associated with operators. Depending on all these things, we try to evaluate, and this is constructed in the bottom-up approach. Since you have only one operation, I would have written B plus C is this. Suppose if you had B plus C star D and all, then obviously we will take multiplication first, followed by addition, then assignment. Even now, if you say we are performing addition first, then we are performing assignment operation. See, this we perform first, then we assign it to ID1. So, syntax analyzer work is to identify whether the stream of tokens developed or generated by lexical analysis is proper or not, first thing. And this is also called as parser. So the process is also called as parsing or syntax analysis, both are same. Since it generates syntax tree as the output, sometimes you also call it as parse tree. So the words would remain different, but meaning would remain same. Remember, syntax tree always talks about rule of a program. All the syntax is what you get. Statement missing, undefined symbol, parameter mismatch. All these things are some syntax errors which all identified at this level. That means for the syntax table, for the syntax analyzer, whatever the syntax to be matched will be fed already. That is with respect to grammar. Just recall. So parsing or parser will take care something about grammar, because you know grammar is set of rules. Then next thing is semantic analyzer. What is semantic analyzer? It tries to check the meaning of the statements. Meaning means what? Whether it is properly meaningful. One best example could be whether is it working properly with data conversions. Say for example, if the same example, if B and C is said to be integer, if A is real, then you may have to convert B and C to real or A to integer, whatever. That type conversion should happen with respect to semantic analyzer, where it just modifies the same value again. The same syntax to whatever we obtained, the same thing is modified in the semantic analyzer as well. No change with that. In this example, there is no such change because I consider all are real numbers. If in case you had some statement, say for example, if instead of C, if you had 25, so I would have written 25 only here. Now, what semantic analyzer would have done, it would have been converted, this ID2 should be added with 25, but this would have been converted as 25.0, where we say convert this to int to float. That means since you say A and B, that means identifier 2 and identifier 1 are real numbers, we have to convert this 25 also as real number. Now this is the modified syntax tree what we have. This is the only extra thing we do. If in case we don't have, we just skip it. That means semantic analyzer is not affecting much to the syntax tree which is generated. Moving on. Next thing is an intermediate code generator. What would happen here? This syntax tree what is generated will be converted to an intermediate code. How do I do it? We usually call it as either we call it as 3 address code or a 4 address code. That depends on the component sometimes or the other factors which will be discussed later in that particular sessions. Now, in this, I will consider 3 address code. What do? I convert this to a 3 address code. Say the statement is A is equal to B plus 25. So what I do? I just say T1 is equal to into to float 25. Then I say T2 is equal to ID2 plus T1. Then I say ID1 is equal to T2. Observe properly what has been done. First step is this, converted 25 to into float, assigned to T1, an intermediate variable, adding T1 with ID2, ID2 is this. added, then that is assigned to ID1. Now this is taken care by intermediate code generator. Again, this is the intermediate form what it generates. This is fed as an input to code optimizer, where code optimizer would try to modify. I cannot say it modifies the source program. It just try to change something with this intermediate form. What? Observe properly. Rather than you saying converting int to float of 25, then assigning it to T1, then performing the operation assigning it to T2, we can reduce one step there. We can say T2 is equal to ID2 plus 25.0. Or if you want to clear much more, say for example, instead of saying ID1 is equal to T2, we can directly write ID1 is equal to ID2 plus 25.0. This also can be written. It depends on how I optimize. Optimization is just try to remove some of the redundant code, some of the invariant code. Say for example, a simple example I could give. Say you have for I is equal to 0, I less than equal to 10, I plus plus. We have written x is equal to 5 by mistake. Now, how many ever times the loop executes, the value of x will not change. Is it not independent of the loop? In that case, even though the source program has this code, optimizer would remove this from the loop and keeps outside the loop. That is one such example. That means thereby you can say you are reducing the time taken to perform the operation. Instead of performing assignment for 10 times or 11 times, I could remove that assignment out. I can keep the assignment outside, so it will assign you once and you can make it program more faster. So that whatever the intermediate form has been generated by the intermediate code generator is optimized by the code optimizer, and code optimizer again gives this to the code generator. What code generator will do? It generates the code in assembly level language. How does it do? It says LD R1 comma 25.0 add floating point or real. I say R1 comma ID2, then now okay, I like then explain ST ID1 comma. Observe properly. First statement is I am loading 25 to register 1, then adding ID2 with register 1, and then the sum value whatever is there in R1 is copying it to ID1. Here LDF indicates load F, that is load floating point, add F is add floating point, STF is store floating point. What is happening here? This is I write it in the left side only. It is R1 is 25.0. It is R1 is equal to R1 plus 25.0. This is ID1 is equal to R1. This is how the explanation or the work goes on. Now, this is the output what a code generator would do. I think roughly you have understood. We'll take one or two examples and work on. Now, there is one more entity to be discussed under this would be on symbol table. It is a data structure which is always used by almost all the phases. Wow! The moment a lexical analyzer encounters any of the identifier, it just dump or it just stores the value, the name of the identifier, the value or maybe the address onto symbol table for future reference. So as soon as you encounter ID1, ID2, ID3, all those things are dumped to symbol table. Syntax analyzer will refer to symbol table, what type of identifier is that it is matching or not and all these things. Refer to that and check whether syntax is correct. Suppose if you get some of the undefined symbol will happen here because your lexical analyzer wouldn't have added those identifiers onto the symbol table. When syntax analyzer wanted verifying if the symbol is not available in symbol table, then it says undefined symbol. Again, semantic analyzer would verify this symbol table for the code type mismatch. If you say the symbol is float and the value what entering int, that has to be done. That has to be taken care. Similarly, all other phases use that. So symbol table is a data structure used by compiler to handle this, right? Okay, that's all for now. Keep watching. Thank you.